Well, welcome back. Now that we know what percents are and how to work with them, we're going to discover a couple other things we can do with them. One of those things is called percent change, or you might hear percent increase or percent decrease. It's the same thing. They mean the same thing. In fact, percent change covers both percent increase or percent decrease. The way that we're going to do it, if we get a positive percent, that means percent increase. If we get a negative percent, that means percent decrease. So here's what percent change or percent increase and decrease actually does. What it does is it compares the difference between where you started and where you're ending, as far as your values are concerned, with your starting amount. That hopefully makes sense. So we're going to be taking how much we changed and dividing it by our starting amount. That's going to give us a percent based on where we started, not the ending amount. That would not give us the correct percent change. So percent change does only two things. It's really, really straightforward. Subtract and divide. That's it. Subtracting gives us the actual difference. Dividing relates that difference to where you started. When doing that, when dividing, you're going to get a decimal. And that decimal we can easily change to a percent. So that's what percent change does. So step number one, what we're going to do is we're going to find the difference between the two values that you're given. If the two values that you're given are increasing, well, then you're going to get a positive number. If they're decreasing, you're going to get a negative number. But the first and foremost thing, we're going to subtract the new amount or the ending amount or the amount that you finished with from the starting amount or from the old amount, from the beginning amount. So we take, the way I like to think about it is new minus old. So we're going to take the new amount, we're going to subtract the old amount. That's what I have up here for you. The first thing you do is find the actual difference between your numbers, new minus old. So again, and maybe you can see it now, if your new amount is larger, has gone up from the old amount, you'll get a positive difference. That means you're increasing, or it could even tell you you increased. If you have a new amount minus your old amount and you get a negative number, that means that your new amount is smaller than your old amount. That means that you decreased. You're going to get a negative difference. It doesn't even tell you stuff like fell or 5% decrease, and that's okay too. After that, we're going to take that difference and we're going to relate it to the old amount, the starting amount, what you began with, because that's really what we want to know. How much did it change from where we started, not from where we ended? You're not going to say, how much did we change compared to where we ended? That doesn't make any sense. How much did we change compared to where we started? Starting amount, old amount, that makes sense. After that, take that decimal and change to percent, and that's about it. So we're really only going to do one example here. I'll talk about one more example regarding percents, and then that'll wrap things up. So let's say that gas prices fell, wouldn't that be nice, from $2.95 to $2.15. Find percent change. So right off the bat, we can read it. It is a word problem. We can read it, and if things fell, we're going to be looking for a negative difference. So it's telling you that you're falling. You're going to have a negative difference here. You're going to have a negative percent. That's going to tell us percent decrease. So gas prices fell from $2.95 to $2.15. Before you go any further, I'd like you to identify what the old amount is and what the new amount is. Where you started, the first thing given to you is going to be the old amount, the old value. Where you ended is what you're paying now, the new amount, what the population is now, how much you weigh now, whatever the current amount is, that's your new amount. Now, be real careful here. Do this in this order. You have to take the new amount minus the old amount to give you the correct value, positive or negative, because that value is going to tell you whether your percent increase or decrease if you're not having an easy time reading the problem. So step number one, we're going to take the new amount. We're going to subtract the old amount. That, in this case, is going to give us a decimal of 0.80. Okay, please stop right now. Don't miss this. That 0.80, this is not an 80% change. In fact, I messed this up. That's negative 0.80. This is not an 80% change. So using our calculators, we have new amount minus old amount gives us the actual amount of the change. It's not a percent yet. To relate to percent change, you have to relate this difference back to your old amount. So how much actual change compared to where you started. That's what gives us the percent, is that fraction, that comparison. So the subtraction part gives us the literal actual change. Step number 2, will we take that difference, including the negative, and we divide it by the old amount. The second number here, not the first number. This is where a lot of students make a mistake. They'll divide it by this guy. Well, what's that going to do? Think about what that's going to do. That's going to relate the amount of the change to what you changed to. That's not giving you the accurate percent change. We want to relate the actual change back to where we started from. That's the old amount. So that's going to be the 295 in this case. And so we got some calculators handy, and we punch this in. We say, okay, 0.8 divided by 2.95 gives us negative 0.2711, or 12. Let's just end it at negative 0.271. Here's what this is telling you. So the one time we get to run through this, all right? How percent change works. A percent increase or decrease, same thing, just one's positive, one's negative. It takes your new amount minus your old amount. It's giving you the increase or the decrease, the actual change. Relate that to where you started, the old amount, by dividing it. Just divide it. If you have a positive number, a positive decimal, that means that you increased. If you have a negative, that just means that you decreased. But this right here is the decimal equivalent of your increase decrease. In step number 3, all we got to do is just change this into a percent. So we would have, hey, remember that? Move your decimal 2 spots. That's multiplying by 1, but represented with 100%. That negative tells us that we have decreased. So you can say that this is 27.1% decrease. That's the negative part of it. Had we had a positive, we'd say 27.1 increase. In fact, you could do that right now if you want to. Let's switch it around. Let's pretend that gas prices rose from $2.15 to $2.95. You'd still subtract them, only you'd have this reversed. You'd have positive 0.8. You divide by 2.15, the old amount, and you get a different percent. But we would have a positive. We'd have percent increase. It wouldn't be the same percent. So that's the way we do percent increase, decrease, percent change in general. I'm going to go through one more example that's not percent increase, but has to do with percentages even still. So I hope this makes sense to you. It's pretty straightforward. We subtract and we divide. Just make sure that what you're subtracting is in order. New minus old, and what you're dividing is crucial. Take your difference, divide it from your starting amount or your old amount or where you began, however you want to think about that. That gives you the decimal, then change to percent. So let's do one more about percents. Let's say that we have, let's talk about Idaho. Let's say that in Idaho, there's about 215,000 people in the city of Boise, which there is. And Idaho is not a very populous state, so as a matter of fact, the population of Boise is about 13% of the population of the state of Idaho. Let's figure out the population of the state of Idaho given those statistics. So you heard on the news, you said, oh, wow, the guy just told me that, man, the population of Idaho is, 30% of the population of Idaho is in Boise alone. That's crazy. That's a large portion of the people in one place. So let's see how much the population of Idaho actually is. So I'll write that out for us, and then we're going to get going on it. Okay, So there's 215,000 people in Boise. That's 13% of the population of Idaho. Let's find that. Now, the reason why I'm giving you this example is to reiterate that these are still word problems. And being such, we can use a verbal model to do this. And the last examples with percent increase and decrease, that was a formula. So we read the problem, I gave you a formula, and we were able to work through it as a verbal model using the formula. Here it's a little bit different. So right now, we don't have a formula for this. We're going to have to do a verbal model. So let's think about what that verbal model really says. It says there's about 215,000 people in Boise. That's 13% of the population of Idaho. Find the population of Idaho. Let's read through it carefully. And again, we're going to be looking for some words that mean math. So there are about 215,000 people in Boise. So we're talking about people in Boise. That's like that is. Oh my gosh, is. That means equals. This is the word that means equals. Okay, 13% of. Oh, of's a big word. Anytime you have a fraction, and you verify this, that is a fraction. So 13% is 13 parts of 100. That's a fraction. Anytime you have a fraction of something, a fraction of something is going to be a multiplication concept. The population of Idaho, find the population of Idaho. Basically, it's telling you here what you don't know. You don't know the population of Idaho. That's going to be our variable. We're going to want to find it. Let's do a verbal model first. So let's see how the story problem or the word problem starts. We start with the people in Boise. Well, the people in Boise, we know that means equals. So the people in Boise equals a fraction of the population of Idaho. That makes sense. Most cities don't contain the whole state. They contain a fraction of the state. So Boise contains a fraction of the population of the state of Idaho. Fraction of population. Well, now we can start filling out this stuff. So do we know the people in Boise? Do we know how much that is? So before the that's, it's only the people in Boise. Since we know how much that is, that's 215,000 people. Equals. What's after the that's? What's after the word that means equals? A fraction of the population of Idaho. Now, what's that fraction? 13% literally is a fraction. So you can write in 13% of. Of is a special multiplier word. It's a word that when you have a fraction, it says fraction of, 13% of, a quarter of, a fifth of, 7/8 of. It means to multiply. So if you ever want to find a fraction or a percent of a number, all you have to do is multiply. That's kind of convenient. If I wanted to find 75% of 1,000, I just multiply by 0.75, the decimal version of that percentage. So 13%, or the fraction of the population, gives us 13% times whatever variable you want to use for the population. Let's say P. Or you can use a big, well, I wouldn't use I, but use P for population. Now, in order for the math to work well for us, we really like percents to be in decimal form. So we have read this a couple times. We identified some words that mean math. That means equals, and of is a multiplier when you're dealing with fractions. So people in Boise has to equal a fraction of the population. That makes sense. That should be logical. Yeah, the people in Boise are going to be a fraction of the total state. There's 215,000 people in Boise. There's, I don't know how many in Idaho, but I know that this is 13% of that population. So let's change this to a decimal. And now here's some questions. Do you have a linear equation? Yeah. You got one variable raised to one power. Can you get that variable by itself? Well, there's nothing to distribute, no combined like terms. There is a fraction. Actually, oh, this is kind of cool. Could you move the decimal 2 spots on all the terms? You could. Do you have to? No, you don't have to, but you could do that. You don't have a constant. There's nothing added or subtracted. You do have a coefficient, and so we can get rid of this coefficient just by dividing. You can move your decimals if you really want to get rid of the decimal, or you can just divide by 0.13. So let's do that. So let's take our 215,000 divided by 0.13, and we get 1,653,846.15. So really, if you get the decimal 0.15, you usually round up with population because that's more than 4.6. It's less than 4.7, I know, but we round up because that partial person still counts as a whole person. So we have a population of about 1.65 million people. That's the population of Idaho. So I heard it on the news, said, hey, Boise's got 215,000 people. That's about 13% of the state of Idaho. Let's go backwards and figure out what the state population is without having to use Google. About 1.65 million people. So that's the idea. Just one more illustration about how we can use a verbal model to fill out a word problem that deals with some percents here. So I hope that's clear for you. I really do. Focus on percent change. That comes up in about every class. And then try some of these word problems with verbal models, and that will generally help. Hope that helps. I'll see you next time.